So equivalent ratios work a lot like equivalent fractions, where let's say whatever I do to the numerator, whether it's multiplying or dividing, I would have to do to the denominator. It's the same thing when you're working with equivalent ratios. Whatever you do to one side of the ratio, you have to do to the other. So the most common way that you'll probably see an equivalent ratio is when we're looking at simplest terms. So if I have a ratio that's high in numbers and I want to make it a little easier to understand, I can use equivalent ratios and my scale factors to get there. So let's say I had a ratio of 40 to 25 parts, and I wanted to see that in simplest terms instead. So I know 5 can probably be divided into both of these. What I do to one side, I have to do to the other. So my simplest terms ratio will be 8 to 5, and then I can't reduce that anymore. Okay, so that's the scale factor that you read about in the lesson. It's a scale factor of dividing by 5, and what I do to the one side, I have to do to the other. So let's use another example of where you're going to be seeing equivalent ratios. Let's say I had a ratio of something that was 1 to 2. So a ratio of 1 to 2, and then I know the sum of that ratio is 3. Okay, and if you saw before on the intro lesson, I really like to, and you guys should get in the habit of this, identifying what each of these parts represent. So let's make this one up because we're just kind of coming up with this example off the top of our heads. Let's say we're talking about socks, okay? And let's say out of 3 socks, one of them might be a black pair of socks, and the 2 will be my white sports socks or something. Okay, so now I know what each of those parts represent, and I know what that sum is talking about. Okay, so if I opened up a drawer and I had 3 socks in there, I would follow this ratio. I know that one of those socks, one of the 3 socks would be a black pair of socks, and then 2 of those 3 socks would be a white pair of socks. Okay, we can also use the ratio to find equivalent. So let's say, we'll start with an easy one. Let's say I opened up a drawer and it was using the same ratio, and now I had 30 socks. Okay, this is kind of an easy one to visualize because you can see that I basically just did a scale factor of timesing by 10, right? I got from 3 to 30, I multiplied that by 10. So if that's the scale factor over here for the sum, the scale factor is going to be the same for each of these parts of the ratio. It's going to be times 10 and times 10. So 1 times 10 will be 10. 2 times 10 will be 20. That makes sense because then I'll have a total of 30. So in that drawer of 30 socks, 10 of them would probably be black, and 20 of them would probably be my white sports socks. Okay. You could also use it for finding the sum, that scale factor. So let's go back to our 1 to 2 original ratio, right, which had a sum of the ratio of 3. Let's say I had a drawer now where when I opened it, 15 of the socks were black. Okay, remember we identified that. Black, white, that's right. Okay, so now in my new equivalent ratio, I see that I've gone from 1 to 15 black socks. Okay, I have to figure out what that scale factor is. How did I get from 1 to 15? Okay, this one's pretty easy. I obviously multiplied by 15. What I do to one side of the ratio, I have to do to the other. 2 times 15 will give me 30. So if I have 15 pairs of black socks, I will then have 30 pairs of white socks. That's going to give me a total of 45 socks in that drawer, if that was the ratios that I was using. Okay, so a couple of, let's look at a practice question actually for this. And before we get to those ones, so let's say we had a ratio of 2 to 3, okay, and then I wanted to know what the ratio would look like if that was all of a sudden 15. Okay, so it's an equivalent ratio. We need to figure out what the scale factor is. How did I get from 3 to 15? Okay, I would have multiplied it by 5. Okay, what I do to the one side, I have to do to the other. So if that was times 5, this side has to be times 5. okay? So 2 times 5 is 10. If it's confusing looking at it this way, you might see some questions that are actually worded like that. Just think of it underneath. That's often an easier way, right? If you saw it like that, it might be a little bit easier for you to visualize how it gets from the 3 to the 15. Okay, so in this case, our scale factor is to multiply by 5. Okay, let's try one more. Let's say I had a triple ratio, and you can have ratios actually, they're kind of undefined in what they'll finish at. You can have an infinite number of ratios. So let's say I have a ratio of something that's 1 part to 2 parts to 3 parts. Okay, and I'll draw it underneath this time. So let's say I need to find the equivalent ratio for those 2 parts there. How did I get from the 2 to the 22? Okay, I would have multiplied it by 11. What I do to there, I have to use the same scale factor for those other 2 parts. Okay, so that would be the 11, that would be the 33. So in this case, scale factor is multiply by 11. Okay, so just so you can understand how we're working with equivalent fractions and scale factors. Okay, so some examples we're going to go through of kind of word problems where you're going to be using equivalent ratios, scale factors, sum of the ratios, and things like that. All right, so if the ratio of Naomi's pencils to Morgan's pencils is 3 to 4, and Morgan has 16 pencils, how many pencils do they have altogether? So this is a little bit wordy. We're going to break it down into sections. The first thing I need to do is create a ratio that represents this. So I see the name Naomi, and I see the name Morgan, and I see that we have a 3 to 4 ratio. So 3 to 4. The 3 represents that first name, right? It's relative to how you read it. So if Naomi's name comes first, she'll be the first ratio. Okay, Naomi has the 3. To Morgan's pencils, he has the 4. Okay, and now all of a sudden we're looking at a case where Morgan now gets 16 pencils. Okay, that's that next part of important information. Morgan has 16 pencils. We don't know how many Naomi has, and what we actually need to do is, now that he has that 16 pencils, how many do they have altogether? So we're going to need to find the sum of the ratios. Before I can do that, I need to figure out how many Naomi has, and I need to know what the scale factor is to find that out. How did I get from the 4 to the 16 of Morgan's pencils? Okay, if I look at this, it's a scale factor of multiplying by 4. What I do to the one side, I have to do to the other. 3 times 4 is that 12. Okay, now I know the ratio. When Morgan has 16 pencils, that means Naomi's going to have 12. If we're following the 3 to 4 parts, I need to know what the sum of that ratio is so I can find out how many pencils they have all together. So 12 plus 16, because I'm adding all the parts, is going to equal 28 pencils all together. Okay, so we started with that first ratio that we knew using their names. We created the equivalent ratio where a case of Morgan has now 16 instead of the 4. We found our scale factor. We used that scale factor to find the unknown, and then we added them together to get the sum of the ratio, or how many they had all together. Okay, let's try another example. Ava and Paul together have 28 toys. They shared the toys in a ratio of 3 to 1. How many did Ava get? Okay, so important things here. Ava and Paul, 28 toys. They shared the toys in a ratio of 3 to 1. Let's start with that 3 to 1. Okay, and again, the numbers follow the order that the names come in. So that 3 goes with Ava. That 1 goes with Paul. Okay, and all together they have 28 toys. This is not the case right now when I look at this ratio. Okay, when I look at this ratio, the sum of the ratio would be 4. It's the 3 plus the 1. I'm looking for a situation where the sum is 28. Okay, and I need to figure out what those two ratios would be if they had 28 altogether. So how did I get from the 4 to the 28? The number got bigger. I know that I'm going to be multiplying or dividing. If the number gets bigger, it's obviously multiplication. So 4 times what is going to give me 28? That's going to be times 7. If I use that scale factor here, I have to use the scale factor here as well. So 1 times 7 for Paul. In a case where they have 28 toys altogether, Paul will have 7 and Ava would have 21. Okay, and our question that we need to be answering is, if they had those 28 toys, how many did Ava get? Ava had 21 toys. Okay, so again, in this one, we had to use the sum of the ratio and almost create an equivalent sum. Then we found the scale factor, and we used that scale factor to find what our new ratio would be. All right, last example. Brainy Games. They stock puzzles and word games in the ratio of 1 to 5. The manager counted 5 puzzles. How many more word games than puzzles were there? So let's go through what we know. We have puzzles and word games. Those are the two things that we're comparing, the two parts, and the ratio of 1 to 5. Okay, and then let's start with that actually. So in the ratio of 1 to 5, the 1 goes with puzzles. The 5 goes with, I'm just going to put word. Okay, goes with the word games. Excellent. The manager counted 5 puzzles. So right now I have a ratio that shows me 1 puzzle. I'm going to be looking for a situation where that manager counts 5 puzzles instead. Okay, and then we're going to be figuring out how many more word games than puzzles were there. So I'm going to be looking for a difference here. How many more word games were there than puzzles? I need to know how many parts there were then that were the word. So how did I get from the 1 to the 5? I got that by timesing by 5. What I do to the one side of the ratio, I have to do to the other. 5 times 5, 25 word games. So in the situation where there are 5 puzzles, using the ratio of 1 to 5, there would then be 25 word puzzles. The question is asking me though, how many more word games were there than puzzles? So when we're talking about the mathematical terms of how many more, that means we're going to be using a subtraction. So if I take away the puzzles from the word games, I'm going to know how many more there were. So 25 minus 5 will be 20. Therefore, there were 20 more word games than puzzles. Okay, so my biggest tip I would say for you guys going forwards with the work is to read the question carefully and then always start with breaking it down into a ratio and writing down what those parts are underneath so that you can keep track of it. Okay, and then usually you'll get a piece of information that you can use to find out what you're doing the equivalent ratio of, and then you just need to find the scale factor and apply that to get your answer. Okay, so go through them slowly. You guys will do great. Have fun.